Hello viewers. So in last session I derived some of the dimensional formulas for physical quantities. See here I have written the rest of the physical quantities. So they are all constant quantities. Boltzmann's constant, Stefans constant, Plancks constant and solar constant. So these are all constant quantities but they have dimensions. Okay. So I told you in previous session also to write the dimensional formula, only the thing is you should remember the formulas of a particular physical quantities. Okay. See here I have written the 4 constant. Now I am going to write the dimensional formula for these constant what I have written here. Okay. Okay then, see here the first constant we have is Boltzmann's constant, which has a formula energy divided by temperature. Okay, so for temperature I have written only in short form, that is temp here, so energy divided by temperature. So this is the formula to calculate the Boltzmann's constant. So it will be helpful for you to solve the numericals. Okay, so Boltzmann's constant is equals to energy divided by temperature. So now I know the dimensional formula of energy as well as temperature, so directly will apply the dimensional formula for energy as well as temperature, and then I am going to rearrange to get the dimensional formula for Boltzmann's constant. Okay, so here the dimensional formula for energy is mL square T minus 2, or you can read this as m raised to 1, L raised to 2, T raised to minus 2 divided by, for temperature I have used capital K. So therefore the final dimensional formula for Boltzmann's constant will be mL square T minus 2, and if I take this K to the numerator, then it becomes K raised to minus 1. So this is the dimensional formula for Boltzmann constant. Okay, so next let's move on to another constant I have, that is Stefans constant. So Stefans constant has a formula energy divided by area into time into temperature to the power 4. Okay, so here I am going to write the same dimensional formula for energy what I have written here, that is mL square T minus 2. Okay, so this is the dimensional formula of energy we knew. And for area is nothing but what? Length into breadth, so it will have a dimensional formula L square. And next for time is represented by capital T. Then I am having temperature, so temperature is represented by capital K, which raised to 4 here, so I should put 4. Okay, so therefore the final dimensional formula for Stefans constant would be see here, L square gets cancelled, and this is your minus 2. Okay, here you are having T. If it take to the numerator, it becomes T raised to minus 1, T raised to minus 1, T raised to minus 2 will become T raised to minus 3 here. And if you take this K to the numerator, again it becomes K raised to minus 4. So this is the dimensional formula for Stefans constant. Okay, and next let's move on to another constant quantity we have, that is Planck's constant. Planck's constant is given by energy divided by frequency, energy over frequency. So what is the dimensional formula for energy? That is mL square T minus 2. So only by practice you can be able to write the dimensional formula. Don't by heart. Okay, don't by heart any of the dimensional formula. Only the thing is you should have to remember the formulas of a particular physical quantity. Then only you can be able to write the dimensional formulas. okay, divided by frequency. How we are going to define frequency? Frequency is nothing but what? It is the reciprocal of time period. So let me write 1 by t for frequency here. So for frequency which is represented by nu is equals to 1 by time period. So if I write 1 by t here, 1 by time, that is 1 by time, okay. So therefore it can be written as, or we'll write 1 by t, or directly we'll write the dimensional formula for frequency, that is t raised to minus 1 here, because 1 by t represents t raised to minus 1. So t raised to minus 1, if I take this t raised to minus 1 to the numerator, it becomes t raised to plus 1. So therefore ml square t raised to minus 2 and t raised to plus 1. Minus 2 plus 1 is minus 1. So this is the dimensional formula for Planck's constant. Okay. So let's move on to solar constant. Solar constant has a formula, energy divided by area into time. Again I have to write the dimensional formula for energy here. I know the dimensional formula of area and time. If I substitute all the dimensional formulas, we'll get the final dimensional formula for solar constant. Okay, so here let me write the dimensional formula for energy, ml square t minus 2 divided by, for area it is L square, and for time it is just t. So therefore here L square gets cancelled, and here you are having t raised to 1. If it goes to the numerator, it becomes t raised to minus 3. So this is the final dimensional formula. For either you can write mt minus 3, or if you are adding L in that, then you can write this as m raised to 1, L raised to 0, t raised to minus 3. In my last session, I told you anything to the power 0 will give you the value 1. So no necessity to write, it is not necessity to write all these things, but if you want to write a dimensional formula in a proper way, then you have to represent like this: m raised to 1, L raised to 0, t minus 3. ಹೀಗೆ ಬರೆದ್ರು ಏನು ತಪ್ಪಾಗಲ್ಲ. Okay, if you want you can write. Okay, so I think we were discussed most of the dimensional formulas here, plenty of dimensional formulas and physical quantities. So ಈ ಎಲ್ಲ physical quantities as well as dimensional formulas ಏನಿದೆ ಇದೆಲ್ಲದೂ ಕೂಡ ನಿಮಗೆ PU1 ಅಲ್ಲಿ ಬರುವಂಥದ್ದು, PU1 PU2ಗೂ ಕೂಡ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. But only the thing is you should have to remember the formulas. Okay. Now let me tell you some of the terms related to the dimensions here. So what are the terms which are related to the dimensions? Some of the terms which are related to dimensions. So the first one is the dimensional variable. Dimensional variable or dimensional variables. See here, the name itself indicates dimensional variables. That means the quantity which possesses dimensions as well as they have variable values. ಆ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ಏನು ನೀವು ಕನ್ಸಿಡರ್ ಮಾಡ್ತಿರೋ ಆ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿಗೆ ಡೈಮೆನ್ಷನ್ಸು ಇರುತ್ತೆ ಆಸ್ ವೆಲ್ ಆಸ್ ಅದು ವೇರಿ ಆಗುತ್ತೆ, ವ್ಯಾಲ್ಯೂಸ್ ಏನಾಗುತ್ತೆ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಸೊ ಅಂಥ ವೇರಿಯೇಬಲ್ಸ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ, ಡೈಮೆನ್ಷನಲ್ ವೇರಿಯೇಬಲ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಹೌ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡಿಫೈನ್ ಡೈಮೆನ್ಷನಲ್ ವೇರಿಯೇಬಲ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ, ಸೊ the quantities which possess dimensions, the quantities which possess dimensions and have variable values and have variable values. Such term is said to be a dimensional variables. So which are they? What are dimensional variables? Do we have any examples on dimensional variables? Yes, we have a physical quantity which has dimensions and the quantity will vary. Okay, the values will get changed here. So what are they? So here, for example, let me consider speed. Speed has a dimension. We know speed has a dimension LT minus 1, and speed is a variable quantity, right? This physical quantity will change. ಹೇಗೆ ಚೇಂಜ್ ಆಗುತ್ತೆ? ಸ್ಪೀಡ್ ಯಾವಾಗ ಬರುತ್ತೆ? ಒಂದು ಪಾರ್ಟಿಕಲ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ, ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಅದು ಸ್ಪೀಡ್ ಏನಾಗುತ್ತೆ? ವೇರಿ ಆಗುತ್ತೆ. ದಟ್ ಮೀನ್ಸ್ ಸ್ಪೀಡ್ ವಿಲ್ ಗೋಯಿಂಗ್ ಟು ಚೇಂಜ್. ಯಾವ ಮೂಮೆಂಟಲ್ಲಿ ಸ್ಪೀಡ್ ಆಗುತ್ತೆ? ವೆನ್ ಬಾಡಿ ಆಕ್ಸಲರೇಟ್, ಸ್ಪೀಡ್ ವಿಲ್ ಗೋಯಿಂಗ್ ಟು ಚೇಂಜ್ ಅಲ್ವಾ? ಸೊ ದ್ಯಾಟ್ ಈಗ 1 km/h, 2 km/h, 3 km/h. ಸೊ ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ? ವ್ಯಾಲ್ಯೂಸ್ ಏನಾಗ್ತಾ ಇದೆ? ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ. ಸಪೋಸ್ ಒಂದು ಬಸ್ ಶಿವಮೊಗ್ಗದಿಂದ ಸಾಗರಿಗೆ ಟ್ರಾವೆಲ್ ಮಾಡ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಅಥವಾ ಒಂದು ಸಿಟಿಯಿಂದ ಇನ್ನೊಂದು ಸಿಟಿಗೆ ಹೋಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಸೊ ಎಷ್ಟು km/h ಅಲ್ಲಿ ಹೋಗ್ಬೋದು ಅನ್ನೋದು ಆಯಿತಾ? ಅಥವಾ 30 km/h ಅಲ್ಲಿ ಹೋಗುತ್ತಾ? 1 ಅವರಿಗೆ 30 ಕಿಲೋಮೀಟರ್ ಡಿಸ್ಟೆನ್ಸ್ನ ಟ್ರಾವೆಲ್ ಮಾಡುತ್ತಾ, ಕವರ್ ಮಾಡುತ್ತಾ? ಅಥವಾ 1 ಅವರಿಗೆ 40 ಕಿಲೋಮೀಟರ್ ಡಿಸ್ಟೆನ್ಸ್ನ ಕವರ್ ಮಾಡುತ್ತಾ? ಈಗ ನಿಮ್ಮ ಹತ್ರ 2 ಬಸ್ ಇರುತ್ತೆ, ಎ ಬಿ ಅನ್ನೋದು 2 ಬಸ್ ಇರುತ್ತೆ ಅಂತ ಅಂದ್ಕೊಳ್ಳಿ. ಸೊ ಅವಾಗ ಎ ಅನ್ನೋ ಬಸ್ಸು ಪರ್ ಅವರಿಗೆ 30 ಕಿಲೋಮೀಟರ್ ಅಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ನ ಕವರ್ ಮಾಡುತ್ತೆ. ಬಿ ಅನ್ನೋ ಬಸ್ಸು ಪರ್ ಅವರಿಗೆ 40 ಕಿಲೋಮೀಟರ್ ಅಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ನ ಕವರ್ ಮಾಡುತ್ತೆ. ಸೊ 1 ಅವರಲ್ಲಿ 30 ಕಿಲೋಮೀಟರ್ ಅಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ನ ಕವರ್ ಮಾಡ್ತಾ ಇದೆ ಬಸ್ ಎ. 1 ಅವರಲ್ಲಿ 40 ಕಿಲೋಮೀಟರ್ ಅಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ನ ಕವರ್ ಮಾಡ್ತಾ ಇದೆ ಬಸ್ ಬಿ. ಸೊ ಯಾವುದಕ್ಕೆ ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಅಂತ ಹೇಳಿದ್ರೆ ಬಸ್ ಬಿಗೆ ಇರುವಂಥದ್ದು ಸ್ಪೀಡ್ ಜಾಸ್ತಿ. ಸೊ ಸ್ಪೀಡ್ ಇಸ್ ಅ ವೇರಿಯಬಲ್ ಕ್ವಾಂಟಿಟಿ. ಸೊ ಇಟ್ ಹ್ಯಾಸ್ ಡೈಮೆನ್ಷನ್ಸ್. ಅಲಾಂಗ್ ವಿತ್ ದ್ಯಾಟ್ ಇಟ್ ಪಾಸಸ್ ವಾಟ್? Variable values. Okay, change values. So the quantities which possess dimensions and have variable values, okay, such quantities are said to be dimensional variables. Okay, for example, speed, velocity, force, etc. Okay, so plenty of physical quantities we have which have dimensions and they have variable values. They change according to the situation, according to the condition. Okay, so let's move on to another term I have, that is dimensional variable is one term. Adre we are having dimensionless variable. Dimensionless variable. So what are dimensionless variable here? See here, the name itself indicates dimensionless anta helidre aa quantity ge dimensions e iralla, but they are having change values, variable values. Okay, but they are having variable values. So dimensionless quantity yaudu hagadre anta helidre illi I told you about angle in my last session, right? Angle is a dimensionless quantity. Angle anta helidre, how we are going to define angle? Angle is equals to what? Arc of a length divided by radius. So length eradu kuda length agutte, L raised to 0 agutte. Anything to the power 0 is equals to 1. So it is a dimensionless quantity. Angle is a dimensionless quantity. Okay, ಸೊ ಆ್ಯಂಗಲ್ ಅಂತ ಹೇಳಿದ್ರೆ ಗೊತ್ತಿದೆ. ಓಕೆ, ಸೊ ನಿಮಗೆ ಗೊತ್ತಾಗಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಯು ಜಸ್ಟ್ ಸಿ ಮೈ ಲಾಸ್ಟ್ ವಿಡಿಯೋ. ಓಕೆ, ಸೊ ದ್ಯಾಟ್ ಯು ಕ್ಯಾನ್ ಏಬಲ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ it is a dimensionless quantity, angle. And one more I have is strain. Strain is also defined as a ratio of change in length to the original length. Eradu kuda length irodrinda allenagutte, it will become a dimensionless quantity. So a quantity which doesn't possess dimensions but have variable values, such quantities are said to be dimensionless variable, or such variables are said to be dimensionless variable, or quantities ಅನ್ನು ನಾವು dimensionless quantities ಅಂತಾನೂ ಕೂಡ ಹೇಳ್ತೀವಿ. ಆಯ್ತಾ? angle and strain. So here this is the example for Example for dimensionless variable. Here I am going to write the definition. Hope you don't mind. Okay, so the quantities which doesn't have, the quantities which does not have or doesn't have dimensions or does not possess dimensions but have variable values, okay, such variables are said to be dimensionless variable, or you can say this as dimensionless quantities. Examples: angle, strain, etc. Okay, then let's move on to another term I have, that is dimensional constant. See, the name itself indicates idu node ನೀವು ಈಸಿಯಾಗಿ ಡಿಫೈನ್ ಮಾಡಬಹುದು ಏನು ಅಂತ. ಓಕೆನಾ? So dimensional constant. See here, dimensional constant means the quantities or the constant quantities which have dimensions, right? The constant quantities which have dimensions. So in my last session and in today's session also we will discuss about some of the quantities which are constant, right? Plancks constant, solar constant, Boltzmann's constant, Stefans constant, gravitational constant. So these are all constant quantities, but I have written the dimensional formula for all the constant quantities. You know how to write the dimensional formula for all the constant quantities. So here I am just defining a dimensional constant as the constant quantities which has dimensions. Okay, such quantities are said to be dimensional constant. Okay, the quantities which possess dimensions, or the constant quantities which possess dimensions. The constant quantities which possess or which have dimensions, such quantities or such a constant term is said to be a dimensional constant. Which are they? So I have already discussed with you. So here I am going to write. In example, it will be a gravitational constant, right? Gravitational constant. And the second one is Stefans constant. And we have Boltzmann's constant. And solar constant, etc. Okay, solar constant, etc. So these are the dimensional constant which possess the constant quantities which possess dimensions. ಯಾವ ಕಾನ್ಸ್ಟೆಂಟ್ ಕ್ವಾಂಟಿಟೀಸಿಗೆ ಡೈಮೆನ್ಷನ್ಸ್ ಇರುತ್ತೋ ಅಂಥ ಕ್ವಾಂಟಿಟೀಸನ್ನು ನಾವೇನಂತ ಕರಿತಾ ಇದ್ದೀವಿ? ಡೈಮೆನ್ಷನಲ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತ ಕರಿತಾ ಇದ್ದೀವಿ. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ಐ ಆಮ್ ಹ್ಯಾವಿಂಗ್ the last term, that is dimensionless constant. See, the name itself indicates here dimensionless constant, the constant quantities which doesn't possess any dimensions. ಯಾವ ಕ್ವಾಂಟಿಟಿ ಇರುತ್ತೋ ಆ ಕ್ವಾಂಟಿಟಿಗೆ ಡೈಮೆನ್ಷನ್ಸೇ ಇರಲ್ಲ. ಅಂಥ ಕ್ವಾಂಟಿಟೀಸನ್ನು ನಾವೇನಂತ ಕರಿತೀವಿ? ಅಂಥ ಟರ್ಮ್ಸ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ? ಡೈಮೆನ್ಷನ್ಲೆಸ್ ಕಾನ್ಸ್ಟೆಂಟ್. Okay, so the quantities which does not have dimensions, or the constant terms, the constant term or constant quantities which does not have which does not have dimensions, which does not have dimensions. Such a term is said to be dimensionless constant. Dimensionless constant anta karitira. So dimensionless constant hagadre yavudagiರಬಹುದು. So dimensionless constant, hope you heard about pi. Pi has a value 3.142, right? Pi has a value 3.142. So it is a dimensionless quantity, dimensionless constant. Pi is a constant quantity, right? Alva? But it is a dimensionless constant. It is a constant but dimensionless constant. Similarly, charge of an electron, it is a dimensionless quantity. Okay, so these are all the dimensionless constants. So these are the terms you should remember in dimension. So basically we are having 4 terms. One is dimensional variable, dimensionless variable, dimensional constant, dimensionless constant. So dimensional variable anta helidre a quantity ge dimensions irutte as well as values ಏನಾಗುತ್ತೆ change ಆಗುತ್ತೆ. ಸೊ ಅಂಥ ವೇರಿಯೇಬಲ್ಸ್ನ ನಾವು ಡೈಮೆನ್ಷನಲ್ ವೇರಿಯೇಬಲ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಎಕ್ಸಾಂಪಲ್, ಸೊ ಯಾವ್ಯಾವ ಕ್ವಾಂಟಿಟಿ ಚೇಂಜ್ ಆಗುತ್ತೋ, ಯಾವ್ಯಾವ ಕ್ವಾಂಟಿಟಿಗೆ ಡೈಮೆನ್ಷನ್ಸ್ ಇದೆಯೋ, ಯೂಶ್ವಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಕ್ವಾಂಟಿಟೀಸ್ ಯಾವುದು ಕೂಡ ಚೇಂಜ್ ಆಗಲ್ಲ. ಆಬ್ವಿಯಸ್ಲಿ ಸ್ಪೀಡ್, ವೆಲಾಸಿಟಿ, ಫೋರ್ಸ್, ದೇ ಆರ್ ಆಲ್ ವೇರಿಯೇಬಲ್ ಕ್ವಾಂಟಿಟೀಸ್ ಬಟ್ ದೇ ಹ್ಯಾವ್ ಡೈಮೆನ್ಷನ್ಸ್. ಸೊ ಅದನ್ನೆಲ್ಲ ನಾವು ಡೈಮೆನ್ಷನಲ್ ವೇರಿಯೇಬಲ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ಸೊ ಡೈಮೆನ್ಷನ್ಲೆಸ್ ವೇರಿಯೇಬಲ್ ಅಂತ ಹೇಳಿದ್ರೆ ಡೈಮೆನ್ಷನ್ಲೆಸ್ ವೇರಿಯೇಬಲ್ ದಟ್ ಈಸ್ ಇಟ್ ಡಸಂಟ್ ಪಾಸಸ್ ಎನಿ ಡೈಮೆನ್ಷನ್ಸ್ ಬಟ್ ದೇ ಆರ್ ವೇರಿಯೇಬಲ್. ಲೈಕ್ ವ್ಯಾಲ್ಯೂಸ್ ಏನಾಗುತ್ತೆ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಈಗ ಸ್ಟ್ರೇನ್, ಆ್ಯಂಗಲ್ ಏನಾಗುತ್ತೆ, ಆ್ಯಂಗಲ್ ಚೇಂಜ್ ಆಗುತ್ತೆ ತಾನೆ. ಸೊ 0 ಡಿಗ್ರಿ ಆ್ಯಂಗಲ್, 30 ಡಿಗ್ರಿ ಆ್ಯಂಗಲ್, 40 ಡಿಗ್ರಿ ಆ್ಯಂಗಲ್, 50 ಡಿಗ್ರಿ ಆ್ಯಂಗಲ್ ಅಲ್ವಾ. ಸಪೋಸ್ ಇಫ್ ಅ ಬಾಡಿ ಈಸ್ ಮೂವಿಂಗ್ ಇನ್ ಅ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್, ಸರ್ಕ್ಯುಲರ್ ಪಾತಲ್ಲಿ ಬಾಡಿ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಫಸ್ಟ್ ಆ ಬಾಡಿ ಪೊಸಿಷನ್ ಇಲ್ಲಿದೆ ಅಂತ ಅನ್ಕೊಳ್ಳಿ. ಸೊ ಇಲ್ಲಿಂದ ಆ ಬಾಡಿ ಪೊಸಿಷನ್ ಇಲ್ಲಿಗೆ ಬಂತು ಅಂತ ಅನ್ಕೊಳ್ಳಿ. ಇಫ್ ದ ಪಾರ್ಟಿಕಲ್ ಮೂವ್ಸ್ ಫ್ರಮ್ ಎ ಟು ಬಿ ದೆನ್ ಎಷ್ಟು ಆ್ಯಂಗಲ್ ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ, ಆ್ಯಂಗುಲರ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಎಷ್ಟು, 90 ಡಿಗ್ರಿ ಅಂತ ಹೇಳ್ತೀರಾ. ಸೊ ಹಿಯರ್ ಆ್ಯಂಗುಲರ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಇಸ್ 90 ಡಿಗ್ರಿ, ಆ್ಯಂಗಲ್ ಇಸ್ changing here, varying here, so change ಆಗ್ತಾ ಇದೆ. So angle is a variable quantity but it doesn't have dimensions. It is a dimensionless quantity. Even exams allu kuda nimage kelbodu. So which just give me the example for dimensionless quantity or give me the example for dimensional constant antanu kelbodu athwa dimensionless constant antanu kelbodu. So you should be able to remember all these terms, which are dimensional variable, which are dimensionless variable, which are dimensional constant and which are dimensionless constant. Dimensional constant, dimensionless constant. Okay, so this is about dimensions. Okay, so in dimensions we studied that what is a dimension. Okay, dimension is nothing but they are the powers in which the fundamental physical quantities are raised to express that quantity completely. So that is what dimensions, and we will discuss about the types of dimensions we have, right? And we will discuss about these terms, and we have learned how to write the dimensional formula of a particular physical quantity. Okay, so I hope you enjoyed this session. Anyway, thank you for giving me a time to discuss some terms regarding dimensions. Okay, thank you everyone.